Alrighty, everybody. So in the last lesson, we talked about how to find the probability of an event. Well, now we're going to find the complement of a probability, and we're going to use some tables to do it. Yay! All right, let's take a moment and knock these out from the last time. Go ahead and get those answers in. I'll give you a hint. So what is theoretical probability, or the expected probability of getting a 4? So remember, the probability of getting a 4 is going to be the number of 4s over the total numbers. Not the number of 4s I got, though, the number of 4s available. So why don't I add that word? And then the experimental probability. So the probability of a 4, that's going to be the number of 4s spun over the number of spins. There, that should help you out with that bell work. So should we have been concerned that when 8 trials were completed, we didn't exactly get 2 1s, 2 2s, 2 3s, and 2 4s? Because if I have 8 numbers, I would expect to get 2 of every outcome. Well, that answer is a emphatical no. No, I should not have been concerned. Probability is only good, I'm going to do that in quotes, at predicting outcomes given many trials. So if I, to use a probability to show how many items I expect, I would have to do it many, 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 many times. And that's what the law of large numbers says. The law of large numbers is that as a sample size increase, what I mean by the sample size means the number of attempts. As the number of attempts I do increases and increases and increases, we're going to get closer and closer and closer to our theoretical probability. In other words, the more times you do an event, the more my experimental probability will get closer to the theoretical probability. So probability only works after many, 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 many trials. It's not good for predicting 1 event or 2 events or 3 trials. It would have to be like 500, 600, 1,000 trials. That's when probability does a great job at predicting outcomes. So if I give you this list of numbers, let's find these probabilities. Let's find the probability of getting an even number. Alrighty, so the probability of even is going to be the number of evens over the number of trials. So how many even numbers were there? 1, 2, 3, 4 even numbers, and there were 15 trials. And that reduces down to 4/15, which if we write it as a decimal, because remember it can be written as a decimal, is 0.27 when I do my rounding. So unlikely to happen. At least a 3. So we need the number of 3s, 4s, and 5s over the number of trials. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 15. Let me just count that there's only 4 I don't need. So 1, 2, yep. So 11/15. And if I write that as a decimal, that would give me 0.73. Boom. What's the probability that I get no more than 2? So no more than 2 is going to be the number of 1s and 2s over the number of trials. Alrighty, how many 1s and 2s are there? 1, 2, 3, 4 out of 15 trials. So if I write that as a fraction, that should be 0.27. Yep. Boom. Easy. Now we have an idea, a concept in probability called a complement. The complement of A is the probability that A does not occur, or not A. Because all probabilities must add up to 1, the following rules / notations are used for the complement. So the probability for the complement of A can also be written this way. So if you see A with an exponent of C, that's the complement of A. A with an apostrophe is the complement of A. That's the same as saying 1 minus the probability of A. 1 is the probability that everything happens. Well, if I don't want A, that's everything minus A. So let's find the probability of not 2. So the probability of not 2 is going to be 1 minus the probability of 2. So the probability of 2, 1 minus 2, let's see, there are 1, 2 2's. So that would be 13/15. Another way of saying that is, let's get the numbers of 1s, 3s, 4, and 5s over 15. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 ways to not be a 2 out of the 15 trials. Easy. Let's find the probability of not 5. The complement of 5 is anything that is not a 5. So you could do 1, 2, 3, 4, 6, or just 1 minus the probability that I am a 5. So that's going to be 1 minus, well, how many ways could we be a 5? 1, 2, 3, 4, 5. So that would be 2/3. The probability of not being a 5 is 2/3. Now let's create a frequency table for these trials. So what I would like you to do is I'd like you to pause the video. Frequency, how many times did a 1 happen? How many times did a 2 happen? A 3 happen? A 4 happen? A 5 happen? And then how many items do we have in total? And then we're going to find the probability that each of those outcomes occurred. So if we do this, if we count up the number of 1s, 2 of those outcomes were a 1. So the probability that we got a 1 is 2 out of 15, which is 0.13. We're going to count how many 2s happened. 1, 2 2s happened, which is again 2 out of 15. There were 1, 2, 3, 4 3s, which would, come on, 4/13. Let me see if I can. There we go. 4/13. 4/15, I'm sorry, which is 0.27. We had 2 4s, which we've already said is 0.13. 5 5s, which is 1/3. So we had a total, if you add these up, 2, 4, 8, 10, 15 ways. And then we add up our percents, 0.13, 0.13, 0.27, 0.13, 0.33. We get 0.99. What I need this to be is, I need this to be 1.00. So in a situation, what I would do in this case is I would look at one of these values and I would go, man, let's change one, let's round one of these up a little bit. So I'm going to make this one 0.28. And that's how I can get that to be a 1. Your probabilities have to add up to 1. And because of our rounding, it didn't. So if I'd have added up the fractions, I would have got 1. But because of my rounding for the decimals, I didn't. So I changed one of the decimals. So what about this one? Hit pause. Find the probability for every outcome, please. Alrighty, welcome back. So our outcomes, you should have told me there were 17 total outcomes, 12, 15, 16, 17. 4 out of those 17s were a 10. You should have gotten these ones. And again, because I'm a little different, 1.01, I don't want 1.01, I want 1.00. And why this is wrong is because of my rounding. So what I'm going to do is I'm going to make one of these just a little bit less. I'm going to round this down to 0.23. And I chose that one because it's a single value, and I thought it was the one closest to rounding down. So, and did I? Yeah, see, that's what I did. So let's use this table and answer these questions. What is the probability, if I'm using the table, what is the probability that x was 12? Well, so that's going to be the number of 12s over the number of trials. So we had 3 12s right here. We had 3 12s. We had 17 trials. And then if I turn that into a decimal, we would see that is 0.18 right here, right there. The probability that I got a 12. What is the probability that we were less than 12? Well, less than 12 is going to be the number of 10s plus the number of 11s over the total number of outcomes. So that's 12 17ths. And if the reason I am redoing the math instead of just adding up the decimals, if you remember, I had trouble adding up those decimals, so I did it again. If you were to tell me 0.70 because you added those decimals, I honestly wouldn't have a fit. Now we're including the 12. Less than or equal to 12, so that's going to be my 0.23 plus 0.47 plus 0.18. And if you're to do it as fractions, I like the fractions because you don't have to worry about rounding with fractions. I like to do fractions. They're my favorite. That would be 15 17ths. I just like that a little bit better. 15 17ths, not 15ths. I like my fractions better. Greater than 12. So how many numbers were greater than 12? It was these two, 1/17 and another 1/17. The probability that was at exactly 14, there was 1 14 and there were 17 trials. Easy. What about that it's between 11 and 14? Include the 11, do not include the 14. So that's going to be 8 plus 3 plus 1 divided by 17, which is 12 17ths. I prefer the fractions because I don't have to worry about the rounding, so just going to do it that way. What about 10 to 14, including both 10 and 14? Well, that's all the numbers. So I have to get one of those numbers, so it's going to be a 1. Probability of 1 means it has to happen. What about 13 or less? 4, 8, that's 12, 15, 16, 16 17ths. So we're going to start off next video with example D here. If you want to pause the video and get a head start, by the way, give it a shot, and I'll see you in the next one.